Hey everyone, Ham here, back today with another Pimax Crystal video. Today I'm checking out a update to the firmware and the software for people that have early access to the device. So because I'm in this trial group, I now have slightly early access to some of the new features, including the eye tracking. So today I thought I'd just go through some of the release notes and just pick out some items of interest. Then I'm going to show you DCS with quad views enabled and eye tracking and show you what it looks like. Right, just looking through some of the latest release notes. Keep in mind this will be subject to change by the time it's widely available for everyone else. But if we look, eye tracking enhancement is now available. So improved functionality of eye tracking feature, automatic IPD. So when you put the headset on, it'll figure out where the center of your eyes are and adjust the lens position for you. There's something here about an enhanced FOV resulting in 5-degree lens to screen angle offset. No idea what that actually means, but we'll be trying that out shortly. What else did I see? Oh, compatibility with the upcoming faceplate release. So if you've got the Steam VR Lighthouse trackers, you can use that now if you have the faceplate. Looks like some controller accuracy improvements there, so that'll be good for first-person shooters. 120 Hz refresh rate optimization, so looks like they've improved that to make that a bit more stable. Integrated all-in-one mode, so this will be the standalone XR chip mode, which I might check out on another video. Charging performance enhancement, so optimize the power supply logic. Extended gameplay sessions when used with a USB hub, elevated VR experience for users utilizing the enhanced power setup. So I'm not sure what that is, but I believe when you've got the device turned off now and still plugged into your computer, it will actually actively charge it now. So interesting to see how the battery life is any different or not. So in terms of software today, I'm using version 1.15.0101. And in terms of the firmware, I'm on 1.3.0 build 829. And if we go to device, you can see we've now got the eye tracking auto IPD adjustment ticked. Wearing location reminder, which basically I think that tells you if the headset is perfectly lined up with your eyes or not. And then the eye tracking calibration button, which is here. So I'll just click that now and get the eye tracking set up. Please look around the surrounding points to confirm eye tracking is normal. If it does not work, please try adjusting it. So right side seems to be working okay, and down to the bottom left. Okay, so yeah, we've got all of them being picked up. So to assist with the eye tracking, I've actually taped the nose covers because I think for my particular face shape, they may have been obscuring some of the infrared eye tracking LEDs, so I've just taped them down on the bottom. So if you're having trouble with eye tracking, this little tip might help you, or alternatively, I guess you could remove them, but if you pull them out, I don't think you can put them back into the face gasket. But I actually like having the nose gap here so I can peek and look at my settings. So before we get started with DCS, I'll just quickly go over the setup process. Now it is a little bit different to say Microsoft Flight Simulator in the fact that the eye tracking for DCS only works with a software application called Quad Views, which Matt, who also wrote Pimax XR and the OpenXR toolkit, he's written this bit of software specifically for applications that implement Quad Views. So I believe this works with DCS World and Pavlov currently. These are the only two games that need this approach. So if you're planning to use the Pimax eye tracking option, or if you have a Vario Aero, for example, or one of the other Vario headsets that has eye tracking, then it's the Quad Views application you'll need to be installed. For Crystal, you'll need Pimax XR Runtime installed. And obviously in the Pimax software itself, you'll need eye tracking enabled. You'll need to have successfully completed the eye tracking calibration. And then over on the Pimax XR runtime, you'll need a little checkbox here, allow the use of eye tracker for it to work with the software. So keep in mind, if you have the OpenXR toolkit installed, you'll need to put it back to its default state because some of the settings will conflict with the quad views application. So you can turn off foveated rendering, for example, as this will override the foveated rendering in the OpenXR toolkit. So just keep that in mind. I'll leave a link to this application and the wiki. It goes through some of the limitations and it tells you how to reset your OpenXR toolkit back to default mode via enabling safe mode. And I think there's a few other settings here that you'll want to do, like you'll want to make sure for the Pimax Crystal, for example, turbo mode is off, because in the configuration settings for quad views application, there's turbo mode is already enabled. So I'll leave a link to this, but just bear in mind this is a separate application that you'll need installing. There's a MSI you just need to download and run. So if you're not sure if eye tracking is actually working, and it can be hard to tell visually, the idea is if it's working well, you shouldn't be able to tell it's on, because wherever you're looking, it's going to be really sharp, and it's just the peripheral vision will be a bit less low resolution, but it's not easy to tell it's actually working. So the easiest way I found is if you go into the troubleshooting section here, and then you check out the information for your specific headset. So something else I'll point out before we get going is you can tweak some of the settings for this quad views foveated app. So if you just go to C, Program Files, OpenXR quad views foveated, there's a settings file in here. So you can see here for Pimax XR, there's a couple of settings we can tweak here, and there's some global settings here. So it says not to change this file. It says if you want to change them, take a copy of this settings file and place them in your local apps data folder. So if we just go there now, we can see there's a log file here, and you'd essentially copy paste in your custom settings file into this directory. But if you want to check if quad views is working, you can open up this log file, and it should give you a bunch of information about the headset and that it's been activated. So you can see on a previous run here, I've got DCS World running, and it's found all of these different options, and you can see under this section here, quad views is activated, and it gives you actual pixel count and what the pixel savings is. So you can see there's quite a dramatic reduction in the number of pixels being rendered. So something to check in order to make sure it's running correctly, because like I said, it's quite difficult to determine whether this thing's on other than looking at the performance difference. In terms of OpenXR toolkit settings, the only thing I've changed is the override display resolution, which I've set to 3100 by 3688. So I've just dropped it down a little. And then under performance, I've got none of the performance enhancements enabled. This is the preset that I've gone for this benchmark. So a mixture here, mostly based on the VR preset. But I've set it, optimized it for performance. Look left, look up, look down, look to the right, look up, look left, look down, straight forward, look to the right, look to the left, straight forward, up, down. So on the left we've got dynamic foveated rendering, and on the right side we've got standard foveated rendering without the eye tracking. And what I noticed was performance isn't that much higher. In some cases it goes up to about 10% higher with dynamic foveated rendering, but the real benefit is how clear it is in the direction you're looking, whereas with standard foveated rendering it's always fixed to the middle region of the image, whereas with the eye tracked foveated rendering it's wherever you're looking, so you can't really tell it's there, whereas with standard, if you look to the edges of the screen you can. So with the second run in the F16 you'll see a bit more bigger fluctuations in the frame rate, and also the CPU usage or CPU timing seems a little better with dynamic foveated rendering as well. So now to make the comparison as fair as possible, in both runs I had the headset on and I was just looking forward, so the fluctuations in frame rate really shouldn't be due to the scene I'm looking at. Yeah, I'm not sure why the CPU time is better with Dynamic foveated rendering, I'm guessing the rendering pipeline is more efficient. Anyway, that aside, the experience was definitely more enjoyable with dynamic foveated rendering. Okay, I think I'll end the video here. Don't forget, if you enjoyed it, leave a thumbs up, and I'll see you in the next one.